All right, so we are back. Where were we? So this is just a continuation from the previous video. We were in the middle of trying to understand what is happening in this puzzle. And I'm trying to remember what we had. So yeah, we had some pseudocode that is basically what one of these blocks in the input program does. We want to have our inputs W match these X values that are what the accumulator said had mod 26 plus something. This 11 is something that varies from block to block. And in some blocks it's negative. And in the cases that is negative, we want these things to match. Because basically we have 7 cases of the 14 blocks. We have 7 cases where we're adding a positive number and we cannot make this comparison be equal. So we have 7 of the 14 blocks. In 7 of them we are going to have the number set multiplied by 26 and then added something. Something that is the input plus another number. This 6 is also something that changes from execution from block to block. Basically, the two things that change from block to block are this 11 and the 6. And then some blocks have basically what would here be set divided by 26. But these are the blocks, let's check them, where then the value that gets added to X is negative. Right, and I also wonder if the order here is -8, then -11, does that match the order? No, we have 11 here, 13 here, okay. But we also have 7 other blocks that could potentially, or do actually, divide set by 26. So what is it what I want to do? Set is getting bigger. And I think I want to have these conditions met, so we don't do this multiplication by 26. Although now that I'm thinking about it, I'm not so sure why set explodes so much, because we have also 7 unconditional divisions by 26. So the multiplication by 26 and adding something more, like, I don't understand why it explodes so much. Is this being discarded somehow? I don't think so. Well, no, okay. So we have 7 unconditional divisions by 26. 7 of them are going to happen, but then we have 14 conditional multiplications by 26. That's why it explodes. They are double. And of those 14, actually 7 of them, we know that they are going to happen. So we must, I think we are forced to avoid the other 7 multiplications by 26. Yes, something along those lines. And what I had as a program, I think this is the input of the program for the last block, I think, or the second to last block. Was it? Yeah, I think it's the second to last block. And when we run this program, we noticed that for some set values, for each possible W value, we can like counteract, so if that makes any sense, this is the second to last. And what were we checking? We were checking that this is 23, so that the last, block can get Z to be 0. Okay. That's fine. What I'm thinking is the first few blocks, I think it was the first 3 ones, were these increments of, so this is the first one, this is the second one, this is the third block, but the fourth one is one where we can where we are adding a negative number to x, and we are also dividing Z, and in this case we really want to not multiply Z again by 26, right? So what I'm thinking is, why not grab these first four blocks and play with that? Because I'm thinking that maybe we can try all the possibilities for the first 3 inputs. That is 9 to the third, that's nothing. And then see which, and also try all the possibilities for the 4th input and see which of the 4th inputs, which numbers there get to decrease the Z value. Something like that. Because we want it to decrease in that last, that 4th block. Okay, so let's copy this code. It's a bunch of things. Gonna parse. We are gonna do something like, not this, but kind of similar. We're gonna have, I'm gonna do basically 4 loops. And this is gonna be W1, 2, 3, 4, the 4 inputs. Please format. And now we see kind of the Hadouken shape here. And we are gonna run this with these different inputs. I think the order, I hope that the order is right. And we're actually going to start with the initial variables all at 0, so like running from the beginning. Then we want to check here, I don't know what we want to check. I want to check that the 4th block decreases the Z value, and print which combinations of the 4 inputs do that. But let's start by just printing the result here. This is gonna be maybe a lot of printing. I don't know. No, it's not so much. So okay, we are around 10,000 in the set. Oh, but look at this. Some of them got, yeah, that's what I wanted. And I also want to probably print the inputs, of course. And look at this, when it gets, oh, that's also interesting. When it gets decreased, it always goes to the same number because it's truncating. That's also interesting. And like, we also know that when we have that division, that we don't have it here, but in the cases like that would be like if x, I don't know, basically if this number is less than 0, is negative, we are also dividing set by 26. And in these cases, in those cases, we want to not multiply it by 26 again. And here it seems that it happened a couple of times. We also have this. Why we have this? Probably because of a previous set. And yeah, okay. Okay, so we have cases that decrease our set, and I think, well, I want to know which ones there are. Actually, let's look at the output. It seems like everything is above 10,000, something like that. Yeah. Well, no, some of the big ones are also less than 9,000, but it looks like, okay, we can check if the result, the Z result, is less than 1,000, and let's print those. So if result, the last variable, is less than 1,000, we're gonna print the inputs that this will be, well, W1, let's copy this, W2, 3, 4. And actually, we don't need any space, I think, because these are single digit numbers. Okay, we have a bunch of them. We had quite a bunch of them, actually, that get set down. Do we want to just keep the biggest? This one? Probably not, right? Because this biggest number might make some future blocks not not possible to avoid that equality condition, and so keep increasing Z. So I don't know if this is like if we can just pick this one as the first 4 numbers, but it's interesting. Let's see if we can figure out something about them. There are quite a few for 9, starting with 9, 8, 7, 6, 5, 4. Okay, there are a bunch of them. And I think at the very least, these are the only 4 initial numbers that we could have. So I think that this actually is a pretty compelling way of going forward. Like, of all the possibilities of 4 initial numbers, these are the only ones that can actually decrease the Z value on the 4th block. So we know that the actual answer that we want starts with one of these 4 number possibilities. I think. How can we progress from here? I do wonder. 7, 8, 9, 3, 7, 8, 9, 4, 7, 8, 9. There is some patterns in here too. So 8, 9. It's always, for instance, these numbers are always 9. Well, the ones that start with 9 always end in 7, 8, or 9. Actually, they always end in 17, 28, and 39. 17, 28, and 39. All of them. All the ones that start with 9. And all the ones that start with 8 seem to be the case too. Interesting. And does that hold for everything? Kind of looks like it. So we are kind of forced to have like the third and fourth numbers must be either 17, 28, or 39. That's kind of forced, it seems. And the other two are free to move. And if they are free to move, does that mean that we can pick the biggest ones? And maybe only these 3 possibilities are the one? I mean, I'm tempted to try something kind of ugly, but just to see what happens. We're gonna copy those, like the biggest 4 numbers, 4 standard numbers, and we can maybe try to force this. And if we know, like if we assume that the answer starts with these 4 numbers, that means that of the 14 numbers, we are fixing 4, and we only have 8 numbers moving around. That's 9 to the 8 possibilities, and that is like, well, 6 zeros is a million, so this would be 100 million, less than 100 million numbers, because it's not 10 to the 8, it's 9 to the 8. So maybe that's something that we can brute force and check everything if it can start with this. And if we find something starting with this, we know it's going to be the biggest model number, because this is the biggest possible start, I think. I always have to say I think, because I'm not sure about anything. So let's fix the first 4 numbers, and then let's go from the least possible one to the biggest one, in reverse actually, from the biggest to the smallest. We're actually not using this initial variables thing. Let's also comment this. Well, let's just pass an array of zeros here. So 4 zeros. Trust the compiler will inline everything. Will this find any answer? I'm also tempted to put some progress thing here, output. We can probably do something like I don't know, let's count. Let's have a counter. We are just going to increment the count every loop, and well, if the count mod, so every million, let's print without a line, let's just print a dot. You're complaining because you probably need a string here, and here I want to ask if it's divisible by a million, and you don't like this because cannot assign to yeah, sure, be mutable. If we run now, well, we probably want to, I don't know why we're not printing anything. Maybe a million is, well, we have executed this a million times, pretty sure. Why are we getting stuck? Is this printing working? Sure it is, yes. Really, is this taking so long? Now it's printing a lot of dots. Or is the printing buffering something and screwing me around? That is also a possibility. Maybe the standard output is buffered or something. I wonder if that's the case. Let's, whoops, what did I, okay. Let's print a line here. Yeah, okay. I didn't know that. It seems like the standard output is being buffered. So we are doing like a million every second. And we said that it was probably like 10 million. We are running this in release, not a million, but 100 million. Right, that is eight zeros, yeah. And we are moving. Oh wait, this is more than 8. What? I'm being stupid. Oh, it's 14. It's 14. I don't know. I was thinking about 12 for some reason. I did like screw what I said about the first 4 numbers. Yeah, we have 10 numbers moving around, and that is a bit much. That is, well, 1 trillion. That is a bit much to brute force, I think. So maybe I could have left it running, but I'm not even sure if this is a correct, like the correct starting 4 numbers. So we have the 4th, up to the 4th input here. So this is 1, 2, 3, 4. We are here. We are computing which possible 4 numbers could be the first 4. The next block is not one of those that divides by 26. So we have more variability again, and the next one after that is also not one of those. That's a bummer. And then we get, it's like they are more near the end, the ones that divide. the set value. All the other ones are going to be incrementing the set value. So what do we want to do? There's also another interesting thing about, let's comment this again and have the other thing. We were running this. Yeah, we notice a restriction on the third and fourth numbers. Like they can either be 17, 28, or 39. And the first two ones seems that like they can take any value, right? 9, 8, 7, 6, 5, 4, 3, 2, 1. And then it does the same with the 8s here. So it's like the first two numbers are free, and the third and fourth are restrained. The fourth is restrained because we need to hit that equality condition there in the fourth block, and probably the third one is restrained too because it has to like leave some sort of well, a previous number so we can hit something there. So what does that mean? I don't know. I wonder if we can do sort of a, just as we did this, like keep iterating whenever we can decrease. Like we know which blocks are the ones, which of the 14 blocks are the ones that can decrease it. It's the last three for sure. This is, I don't know, maybe two in the middle that cannot decrease. These three and the one that we already did, divide set by. So this one also, which was the fourth one. So we can know that, like we can maybe split the input program into the blocks, tell which blocks are the ones that can decrease the set, and then what? Make sure to pick the right input in those cases, I guess. I kind of guess, I'm not sure. What if we... I'm tempted to do something, again, kind of stupid, but we can do stupid shit forever until we find something. So this is the first 4 blocks. Okay, let's separate those here. This is the one. This is the, yeah. So up to here is the first 4 blocks. Then we want, I think, up to here. Then that is the next 1, 2, 3 blocks, I think. Yeah. The next 3 blocks, maybe we can do something similar than this. right, so with this, we have this result. Yeah. What do I want to do? I want to execute the next 3 blocks with all of these possible starting 4 inputs, and then vary the next 3 inputs and see what we get. If we get, I'm curious to see if we get a reduction of the cases that get this next block to decrease. So what is this? This goes up to here. And here, I guess we could count how many met this condition. I would like to have something not so hard-coded here, but it's fine, I guess. This is probably 9 times 9 is 81 times 3, because we saw that for each combination of the first and the second one, we had 17, 28, and 39 as the third and fourth number. So I guess it's, if I'm not mistaken, 81 times 3, which is what? 243. Is that correct? Let's say, hey, let count again be 0, another count variable. And here say, hey, increments me count. Let's just print. I know that there is a debug macro. Yes, 243. I can multiply. What if we try out? What if we save all these numbers? Do we need to? Do we need to save all these numbers? Actually, I'm also interested just to know. Another interesting thing is if the Z values are unique, and they are not. We can clearly see that each pair of 3 seems to match to the same Z, and Z keeps increasing. But that is interesting. So that is very interesting. So it means that between these 3, we can safely choose this one, the biggest one, because the 3 of them leave the same Z variable set, at the same value on the Z variable, and that's the only thing that affects the rest of the program. That's pretty nice. Yeah. So we can, for each set of these 3 numbers, we can safely choose the biggest one to try out. If one of these 3 is a possible start for a valid model number, we can pick the biggest one with certainty. And what I'm interested in is, what if we get all those set numbers, and and check the rest of the program, that at least the following 3 blocks, starting with each of those set values. Yes. That seems promising. So let's say let z's. Let's use a hash set. Do I need to keep also? Probably also want to keep the inputs. Well, I'm not sure. Let's first keep just the sets. I guess we can get rid of this count. Don't need you. So then sets the other way around. Insert, or how was the push? No. Or maybe import the correct thing. Yes, import this and insert. Yes. Insert the value of set. Why don't you like? Cannot borrow, of course. We have the unique sets, and now this should be 81, I think. So let's debug this. Sets length. Yes, 81. Pretty nice. And then we can do something like for set in set iterator, we're gonna try to vary the we're gonna do something similar to this, but for the next 3 W inputs. So this would be W5, W6, W7. The program that we are gonna run is actually this piece of the input program. Yeah. Let program 2 be this. No, actually this is input. Let's call it input 2. Whoops. Input, not 22, 2. Then let's program 2 be parse this program, this input. This is sets iterator, and we can dereference here. We're gonna run the second program with W5, 6, and 7, starting with that set value. Yes. Right? I think so. Well, in this case, we have 2 blocks that are going to increment, like multiply by 26 twice, and 1 block that might divide by 26 once. So what does that tell us? I don't know. Let's just print here. So let's say for W6 567 and Z equals Z, this is gonna be the result. And I think I don't want to do the first printing. What do we get now? A bunch of outputs. But yes, some of these outputs are smaller. So 6700. And are they all 6700? That is very interesting if they are. Oh no. Double 69. Well, 6699. That's like double nice, I guess. Okay, and the other ones exploded quite high. So let's add an if statement asking if it is less than 10,000. If this is less than 10,000, only those cases print. So less output. How many? Well, they are definitely more than 81 lines printed, because it took some time to do so, I think. Like, yeah, it does look like quite a bit of possibilities. But the unique values, because they are more repeated now. So what if we do just that we have sets before? Let's have another set of sets. Let's call it sets 2. And add this to sets 2. So sets 2 insert this, and let's print the size of sets 2 after this. 618. So we have more unique set values to check. Okay, that's interesting, I guess. But okay, one more interesting thing actually is that, okay, I cut the thing over here, but the next 2 blocks are also blocks that can decrease the, they can decrease Z. And if they do decrease Z, I think we are going to get less possible Z values. That is pretty neat, I think. Should we try that? I wonder if any of this makes sense, or how I will express this in like a better solution afterwards, but I shouldn't worry about that. Let's maybe keep going. We have 600 and something unique set values. Okay. Let's continue with these 2 things. So I don't know if I want to nest them over here, or do something like, hey, let input 3 be this, then do something like this again. Isn't this beautiful? Program 3 is parsing the input 3. we're going to have sets 3, we're going to iterate through sets 2, we're going to have the next W, so this will be W 8 and 9, because this is only 2 blocks, yes, 2 inputs. We can get rid of this for loop. Okay, we're going to run for inputs 8 and 9. Starting with this set, sure. Well, let's remove the if. We know that we are going to put an if there, for sure. But let's not do any of this now. I want to see... Okay, we could actually kind of eyeball it. So, in these cases, it's either going to be like we want to have 2 divisions by 26, so these numbers I think are going to get quite smaller. I think 8, 9 with Z equals Z. Oh, I made a mistake here. Yeah, you are not being written to. That's fine. Let's run like this. Where do we get? Wait, this is panicked. Insufficient inputs for program. Where did you? Well, yes, you're panicked there, but can I have a backtrace? Rust backtrace. But I guess it failed in the panicking, blah, blah, blah. It's here, it is here, sure. And in this, why do you need more inputs? You have 2 inputs, right? You have only 2 inputs. Program 3. Oh, because I'm not running program 3. Okay, I had an unused variable that a warning that I didn't pay attention to. Okay, so we have now more output. Oh, yeah, but I don't have the condition. So now we are having smaller numbers still. That's quite interesting. The largest ones seems to be over, well, at least over 1,000. And we have some pretty smaller ones. So I would put, oh, yeah, 12. So this is probably like a double division, and this is a single division, I think. Although it looks like too much, going from 8,000. Because not only when you do the division, well, you do the division, you avoid doing the division you always do. You avoid the multiplication, that's the thing. Multiplication by 26, but this times 26 is not something. Yes, it is. Okay. I had one more digit in mind. And I guess that these are like the luckiest ones. Yes. So I think a better way of doing this would be going through each block and when you can decrease, keeping only the inputs that decrease. Yes. I don't know, something like that. But let's put the condition here. So yeah, I would say less than 1,000. Let's have sets 3, and this, if this is less than 1,000, we are going to keep that and print the length of sets 3. I want to see if this went down, and it did went down from the number of sets too. And we have these kind of numbers, but we also have very small ones like 12, 7. I think those are the ones that we want to keep, actually. So if we ask if it's less than 100, for example, yeah, we only have 8 possible set values. And for those possible 8 set values, we have a bunch of 9 inputs possible, but we should keep the biggest of those. Yeah, the biggest combination of those inputs. That would make sense. It would make a lot of sense. And now that we have gone up to input 9, we can definitely brute force the rest, I think. Like the rest of the program. We have gone up to the 9th input. We are only missing 5 more inputs. We can totally brute force that. And we only have to check 8 starting set values. I think we are approaching something. Now we have to know, I'm losing information here, like I'm losing which sets which set values which inputs correspond to those to each of the set values. And I think maybe I could keep them if I used, instead of hash set, maybe a hash map. This is a mess of code. This is so messy, so freaking messy. But it's lovely. It's it's lovely. So yeah, I don't want to refactor think too much because I'm going to lose the train of thought. So let's try to do that. Keep the inputs. So I want to know for each of these possible 8 set values after the first 9 inputs, 9 good inputs, which is the biggest of those 9 inputs so far. Yes, that is what I want. And we can do what? What is the mess that we are printing? We are printing a lot of shit, but that's fine. The first sets we are not printing. So what if we say, hey, you are gonna be a hash map instead. Okay, and these are gonna be your inputs. Okay, and we are going from 1 to 9 in each case. So I guess if the entry already existed, now it's going to be a bigger input, because we are going from the smallest to highest. I don't think I have to do a calculation, I think. Yeah, let's do panic here, or I don't know, abort, like I don't want to execute the rest. what do I want to do? I want to maybe get this printing back, and maybe here insert the inputs. Like if it was already there, I don't know, maybe that makes sense. We can print line the sets in debug mode. What's your problem? What's your problem? Well, okay. Don't panic. Let's just comment the code. Up to here, comment. Beautiful. Let's run now. Yeah, hash set is unused. Okay, so we have this. We could check when the set is, for example, I don't know, 412, let's say. Let's look for this number. The one that stayed was 9839, which is the highest of these three. So yeah, this seems to be working. This seems fine. Beautiful. Let's uncomment this. I have so little idea of what I'm doing. But okay, I kept the biggest inputs that give us that set. So now that we are iterating over here, we have this set, and I think we should keep the inputs, right? So let's call it set inputs. Sets iterator. We are iterating over this and this. Fine. Sets2 should also be a hash map. Sure. We are gonna extract this into a variable inputs. So these are the second inputs. Here we shall pass set dereferenced. And what are we gonna do? Can we, I don't know if there is syntax for concatenating to arrays. We shall see. So we have these inputs. What I want to put in sets2 for this value of set is the previous set inputs plus these ones, basically. So we keep everything. Can we do that? Set inputs. Is there a concat or something? It says into the. What does concat do? Oh yes, it seems like it does what I want. Concat it with the inputs. Inputs. You don't like this? Because... Why does this expect a reference for a 4? I want this. Oh. This is an array of, okay, of arrays. Come on, give me Rust concat arrays of different length. I don't know what I did there. Probably Control Enter. How do you join multiple arrays of different length together? As slice concat. Yeah. I don't want a slice though. I want a freaking array. Come on. I don't want to think about this. Can I have something like let all inputs be well, this is what I want to do. Of course it doesn't work, but can I have something like append, extend? Cloning to blah blah. Can I have something like an array with these, and just let's hardcode W5, W6, W7, not hardcode, I mean use the variables here. What are you? Yeah, no, what I want is sort of something like this, or like this. Now this gives me, this is nice. Can I dereference you? What the fuck is happening here? Range from, no, I don't want a range from thingy. Well, I don't know. Let's do the manual thing here. Don't care. What are these things? W1 to 4, right? Yes, this is exactly what I want. I want this to be the set inputs. Sure. And then I want this inside of this. Beautiful, beautiful. I'm going crazy with this puzzle. Okay, now we have all of this. All the inputs, hash map of arrays of 7. Great. And then we can do the same in the last iteration. So let's have a hash map here. Let's do it again over here. Set inputs. Beautiful. It's gonna be these. Then we're gonna do this. Perfect. And we're gonna what? Insert. Well, something very similar to what we had before, although it's gonna be longer. So we're also going to have W5, W6, W7, and we're going to insert into sets 3 all of these plus the new W's. This will be W8, W9. Ah, such a beautiful code. Feels good. Feels good. Look at the minimap here. Beautiful. And instead of printing this, let's print it as debug. the whole thing. Should be 8 values. Well, it printed it with lots of space. But yeah, it is these values I've said, and these are the highest inputs. They look a bit suspiciously low. Like 7. Like there's a 1. Was there? Yeah, there's one that starts with 1. Weird. But okay, let's trust this. Let's trust that we are doing the right thing. Up to this. So what do we want to do now? We want to brute force basically the last chunk of stuff. So the rest of the program, we are going to can basically try all numbers. How many are we missing? 5 inputs, right? Yeah, it's gonna be 5 more. I'm a bit lost or nervous about this. It's like I feel close to something. Okay, let's continue the ugly way we were doing before. Let's copy everything actually. I could try to run the whole program, I guess, because we know the inputs that we want to try. Yeah, we could brute force it like that, I guess. But we have to try with each of those possible set inputs. Does it make sense? Maybe that makes sense to do. Okay, we have those set 3s. Let's uncomment this mess that we had from the beginning. This will read the whole program. Maybe we can skip empty lines when we parse the program. Split white space. Filter lines if the line empty. Well, filter the ones that are not empty. Oh no, this is parse instruction. We are already in a line. I want to do that, but inside of here. Okay. Yes. And what I want to do, okay, is parse this thing. Get rid of this count. Yeah, bye. We are going to brute force the last 5 numbers. So for set and set inputs in sets 3 iterator, we are going to do something like this, terribly ugly. Okay. For each of these, yeah, not printed here. We are going to go like this. Only 5. This should be an array of 5, 5. Inputs are gonna be these. It's an array of 5, sure. Okay. And we need to start with the set value that we want to start with. So it's gonna be 0, 0, 0. Oh no, we actually don't, I think we don't need that because we are not executing, we're executing the whole program, so we can leave this empty. We can ignore set, I think, at this point, because we are going to get there anyway. I don't know why I'm trying to brute force this. I could have used the same approach as before. This seems pretty dumb, but let's continue. We have these inputs, but the actual inputs should be these set inputs concatenated with these other inputs, right? And can we have that? Can we have something like, let's all inputs be an array of 14 and say something like all inputs. I don't know if Rust actually has this kind of syntax. From 0 to 10. This is, yeah. No, this is actually from 0 to 9. Can you be this? Inputs? Do you have syntax for this? What's the problem here? Okay, this cannot be known at compile time. Okay. Sure, let's move this out of here and say, hey, just have for I in 0 to, or just W in set inputs iterator, numerate, blah 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 blah. All inputs, this will have to be mutable. The input in this I is gonna be W. Right? Why do you, yeah, go ahead with that. Okay, we have that, and then this all inputs is what we are going to use here. And we're gonna do for very similar for this, but in these inputs, and this is gonna be 9 plus I guess. Yeah, beautiful. I don't know if I made some stupid mistake there. But I guess we are going to try to run brute force from 99,000 blah blah back to see if one of these gets is set equals 0. And once we found one, we just break out of this loop and we also try some other inputs. And model number, not S, it's not going to be S, it has to be model number, all inputs, join, just join it with empty string, and you don't want that because I guess you need to be strings. Yeah, sure, let's do that. Map to ww to string, join. Yeah. Okay. Let's run this in release mode. We didn't get any any model number blah blah is valid. Meh. Can we print this print line, this set3 as debug? What do we have there? We also didn't crash, but we did something wrong. Okay, let's do something pretty dumb here. Let's have all these inputs. Let's see if we made a silly mistake over here. Trying out well, we're gonna print all inputs. And just break after one. Wait, is program not being used? Why not? Oh. Blah 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 gives us these results. Okay. Oh, I think no, I don't think I don't need to set Z here. They are not very humongous numbers for Z. That is promising. And we are trying it with, seems like, with the correct inputs. So what are we doing wrong? We don't get anyone with a low set value. That sucks. Like in the last 3 blocks, we do have a division, like 3 divisions by 26. We should hit 3 divisions at the end. Like we should hit 2 multiplications by 26, but then 3 divisions by 26, and that should bring these numbers, which are all less than 26, like the remaining Z numbers, down to 0. So what did I screw up? Well, I don't know. This definitely is not correct. Let's print a lot of noise. Do we have any small numbers? Oh, here we hit 1, for instance. This is probably one of the divisions going fine, but we need 2 more to actually go down to 0. Right? It's weird that we are not, like, but by brute force, not getting that 300. Let's say, hey, if the set value is less than 1000, let's print this, see what kind of numbers we get. Yeah, we have 200. We also have a couple of less than 100. I guess that will be 2 divisions going fine. But we don't have any zeros, it seems. Which is weird, I think. Not understanding that. Let's print the ones that are less than 100. Surely have no zeros, right? Well, if we had, we would have prints of the this, but we didn't. Do we have anything less than 10? Yes, we do. But just a few. Huh. I am kind of suspicious about this. I don't know where I screwed up, and this is kind of a mess of the code. But I kind of trust the logic, the main logic that we had of trying to hit all the divisions and avoid any of those multiplications. This minus 14 is kind of weird. Maybe we don't have any W. Like the last three blocks should be able to divide the inputs, and maybe in one of them we don't have any W that makes that condition happen. But if so, does that mean, because we are only keeping the sets that made the divisions possible. Maybe some of the conditions, like one of the possible errors could be some of these horrible conditions that we have, like very hard-coded things that we had. Yeah. Sure. I was a bit confident there that we might get something, but we didn't. we didn't. Maybe I can give another try. Like, I'm not sure about this code, to be honest. It's quite ugly. And this thing with the program. Let's comment it, like with the whole program. Let's do instead something like the same horrible mess that we were doing before, but hard-coded for the last 5 cases. You know, what could go wrong? This should be the last one. Input 4 should be what? Well, all of these. Okay, so program 4 should be parts of the input 4. Sets 4 well, it's going to be a new hash map. We're going to iterate over sets 3. Are the other things correct? Yeah, yeah, yeah. What a mess. Gonna iterate over this, and we are gonna have, well, not 2 but 5 for loops going from W10, 11, 12, 13 and 14. Beautiful. 1, 2, 3, 4, 5. Maybe I did one extra. Oh, look at that. Now the the formatter doesn't want to format my code. That is a sign of doing things right, isn't it? Am I even closing the right amount of? No, I don't think I am. No, yeah, it actually can format my code. So beautiful. Okay, we're going to run this 4th program, which has only 5 inputs, with these 5 inputs: W10, 11, 12, 13, 14. We're gonna start with those sets that we had before, which were pretty small, right? And we're gonna hit 2 multiplications by 26, and we want to hit 3 divisions by 26. So let's, yeah, well, I guess let's print the ones that are less than 100. And we are gonna do this mess here too. 11, 12, so 14, 13. Beautiful, beautiful. Then the inputs are gonna be man, I don't want to confuse this number, so it's all of this, beautiful, plus all of these. What we are going to insert in sets 4. And let's then print this sets 4. Sets 4 as debug print. Why don't you like this? Because I cannot type. It's sets 4. Okay. Are we executing the correct program? Yeah, program 4. Okay. What about now? So no, it seems like my face is on the way. We don't hit 0. We are kind of similar to when we brute force this. So there is one of those three blocks for which we don't hit the division. It seems so. What are we printing here? If it's less than 100, so we are printing that. All of them are with what an amount of noise. Yeah, but we have quite a few. We start with set 13 and we end with set 11, for example. That's not cool. We have different inputs, but we never reach 0. How can this be? Does this mean now I'm doubting about everything? Maybe I made some stupid bug, but I don't know. I'm questioning my logic here. Well, the logic for writing this code is of course questionable, but I'm questioning like this idea of having to hit all of the divisions or avoid all of the possible multiplications to avoid, if it does make sense. We could also I want to try maybe like a more sequential approach to this. Of course, like better code, but I think that this could probably be done more sequentially. Instead of chunking this by chunks of different size, like I went from 4 inputs to 3 to 2 to 5, like just a total mess. I wonder which of the 3 divisions here we are not hitting. We are not finding a W to get there. I don't know if it's, yeah. I think I want to generalize this and try to understand it some other way, because I don't know, I kind of like this logic of, hey, you need to hit these or avoid all of these possible multiplications. There are 7 possible of them, or sorry, that there are 14, but 7 of them are avoidable, and doing that, like, this makes sense in my head. If we don't hit it, how does the last 5 chunks look like? We will add, we will be multiplying by 26 and adding 6, then multiplying by 26 and adding 9, and then we should be dividing by 26. But if we don't divide, here we'll be adding 15. Here we'll be adding 4, and here we'll be adding 10. How does the difference look like? So let's grab the first one of these. We start with set 13 and we ended up with set 11. Okay, so let's grab a terminal maybe. You probably cannot read any of that. So okay, we started with set 13. If we do this times 26, and 13 is half of 26, man, I'm starting to think like a numerologist. We are gonna multiply by 26 and then add the input plus something. So it's gonna be the first input W plus 6 is the first one. Yeah, and the first input is 3. Right, so this is plus 3 plus 6. This is plus 9. Then all of this is gonna be multiplied by 26 again on the second block, and like it's gonna be multiplied here, and we're gonna add 9 plus the second input. The second input is 1, so we're gonna add 10 here. This is 9032, okay. But then, if we hit a division by 26, should get that. If we hit another division, we should get 13, the same number that we started with. And well, if we do it another division, of course, we'll get to 0. But that's not what's happening. We are missing one of those, and it's not the last one. Maybe we're missing the second to last. So let's see. If we are missing the second to last, instead of dividing by 26, we're gonna be multiplying by 26 again, right? I think so. And adding what? This is the second to last. So let's assume that this input went well. Then this one adds 4 plus this input 1. So 4 plus 1 is 5. We got to here, and if this we divide by 26, what do we get? No, wait. If we miss one, am I interpreting wrong what happens when we miss one of the... So maybe we just don't multiply by 26, but we should. Man, this code, I'm just getting lost with reading this so many times. We divide set by 26. We multiply set by y if x, yeah. Okay, this condition still makes sense. I mean, we should always, I think. I find it really weird that we could go from 13. Like, I'm missing something because I was assuming that when we miss a division, it means it goes to a multiplication, but these numbers are greater. The numbers that we get instead are on the same order. So it's like we did 2 multiplications and 2 divisions, which is super weird. It's super weird to me. Yeah. Here, look at that. 9 goes to 9. It's like 2 multiplications and 2 divisions, and that, I don't know, doesn't make any sense to me. What if we pass one less input? This should explode. This should complain about insufficient inputs. Yes, it does. Okay, so we are reading, oops, we are reading the 5 inputs here. That is correct. What are we missing though? Maybe we can follow one of these successful runs and see what happens. Successful, I mean less than 100. They don't get to 0, but they get close, I guess. Yeah, let's do that. This amount of for loops. So how do we do that? Because we are using the run alu program everywhere. We want to, I don't want to do it by hand by any means. Yeah, because it's really weird that this thing does 2 divisions and 2 multiplications. Like I don't understand. It's like this analysis is wrong. It probably is. I mean, I'm not surprised by that, but how can we do this? Well, let's run it again, and if it's one of these cases, let's do that insertion and blah blah. Let's run it again and exit. Panic. Goodbye. Okay. But I want to run it sort of with a debug thing. And yeah, this is horrible, but let's do it. Debug, bool, and this breaks all the other calls. So in the other calls, let's pass false. False, and false, and false. Okay, and now let's do something about this debug thing. Let's print, maybe I don't want to print all of the instructions. Let's, because the program is a bit long, I guess. Well, let's actually print all. So if debug, do the printing. Whoops, and let's run it like this and see what the hell happens. Okay, it's not that much. We are starting, did we print? Let's see first, how are we printing this? we did print this. Okay, so with this input and this Z, we get this. Okay, we have the first input, fine. This first block should increase Z. So yes, it does, for sure. And it does increase it to something similar to what I calculated here. So it was, it's not the set that starts with 13 though, but does it do like 11 to 95? No. So did I compute that incorrectly? What is that? So to here should be this. 3 is, and Z it starts at 7. So now this should be 7. Yeah, 191. Yes, okay. I was more or less in the correct track. So the first input increased Z. Then the second input should also increase it. Okay, it does. 4,000. Now the third one, oh, but this is, no, this is one of the successful ones. Okay. The third one, it does decrease it again to 191, so that is correct. The fourth one actually goes down to 7. Okay. But it doesn't increase by 26 nor decreases. So what the hell? Divide Z by 27. This happens here. Then we have this. We add this minus 14. We get minus 7 in here. We ask if x is equal to w. W is 1, so now x is not, no, sorry. What is the w? Yeah, w should be 1. What's going on here? Oh no, they are not equal. Here, this is the variable. So of course, minus 7 is not equal to 1. But we could have, we should have, when the input is 7, this should work. Like we should have an answer that gets to 0. Right? Like, what's happening here? So like, yeah, okay, we divided Z by 26, but then we end with this yeah, you ended with y equals 26, and this, well, Z is 0 here, so it remains 0, but then we end up adding something to Z. We add the value 10. Var w. We insert. Wait, is this what I? Yeah, w plus 10. Sure, that's 11. Then we multiply by x, which is true, but shouldn't be. We should also run. Like, that doesn't make any sense. Why don't we like this was for this input, but the same input ending with a 7 should give us, I think, a set of 0. So why didn't we get that? Well, I guess we are saying goodbye here. But if we go and run like this, let's go to the first possible. I don't remember what number it was, and I don't know if the iteration order. The iteration order, I think it should be deterministic. Like the hashing is the same. Yeah, it was this. Oh no, okay. What? Why is the 7th case not working? Oh no, we were doing -14 and we got -7. Oh, we need a set value, of 14, or even one more than 14, 15, to have an input that could equal it could be 1. And we don't have a remainder set like that, right? Yeah, I think that's kind of the problem. We don't get any possible set at the end that can help us. 14 is 1 short, because the last number that we compare to is -14. And so we need to, if we have a set of 14, for example, this would be mod of 26 is 14, and here, so it's like we need a bigger reminder for Z. That's tricky. That is tricky indeed. Then we add this to, yeah, we need it to be like 15. So when we add -14, we have 1. Otherwise it's going to be 0 or something less than 0, and no input is going to match it. So X here is like the set that we carried through has to be more than 14, but less than 26, because if it's more than 26, when we do this division, we are going to have some reminder instead, and it's not going to end up as 0. So it has to be between 14 and 26, and we don't have any of those in the possible sets. So I wonder if I, like, where is the error for this? I can think of two possibilities. One could be that one of these conditions of less than something to keep that said is wrong, and we are missing some important ones. Or that the whole thing is wrong, the whole approach, and maybe you can skip one of the first divisions. No, that doesn't seem right either. I think you have to hit the 7 divisions by 26 and avoid those 7 multiplications. Yeah. Damn, I feel like we are so close, but yet so far. Yeah, here we are adding this unconditionally to W, so, well, not unconditionally, but X has to be the right condition, and we couldn't get that. So let's maybe check on the first pass. We're asking if it's less than 1,000. That seemed reasonable, but maybe I'm missing something there. So let's do this, and let's print this, and panic by. Unreachable, yeah, sure. Okay, we do have these numbers, which also seem to be pretty safely under 1,000. Like, I don't think I'm missing things here. If we print maybe less than 10,000, do we get more? We do get more. Yeah, but we get these big ones that don't look like they are hitting. So this was 4 inputs. If we do 27 4 times, no, not times 4, but to the power 4, that's a lot. That is more in this range. So, no, I guess the first one, on the first one, 7 is gonna, like, Z is gonna be small after the first block. Then we are gonna hit 2 multiplications by 26 for sure, and 1 is the one that we want to avoid. So let's say we have a small number like 10 times 27 squared, something around there. That doesn't look too good. Yeah, but I mean, let's go, let's print everything. It's like around 10,000. Yeah, I mean, And 10,000 divided by 27 is around this number, so this is like hitting that that division by 27. Yeah. We could ask less than 5,000, but I guess with this I should get the same answer as before. It looks like the same answer as before. Okay, so let's assume that this is fine. We shall continue to the second input. In this one, we had two unconditional multiplications. Maybe this condition is wrong. Yeah, let's take a look at this. Let's do this unconditional print. Let's print that, and let's panic here. The numbers here, yeah, these numbers are much bigger. So maybe here I am missing something by asking less than 10,000. This is 7,000, 7,000, blah, blah, blah. Other bigger. So we are asking less than 10,000. Let's run it like this. Oh, look at this. We are very close to. This is very close. Okay. I think here I made a mistake. Let's ask less than 50,000. I guess that I wager that we are going to get bigger numbers. Oh. Wait, 727 versus what was before? 618. Okay, this seems promising. We go over this. Why I'm running this again? Okay, now we have more candidates, and we have some that we were missing before that are over 10,000 by just a bit, but maybe those numbers are exactly the ones we need. So let's do everything again. And run. Do we have a set equals 0 in here? One of these. Yes. Yes, we have a key for 0. Oh shit. Do we actually have this? Let's ask if this is equal to 0. We don't need to insert anything. Yes, we got a number. Oh man, and we only have one actually. We were trying with all the different sets from previously, of which, now we have a 15. Okay, so maybe the model number is unique. What do I want? I want to have this printed. Come on. What do I want to do? Just print this. Oh no, this is the same as. No, I want this. Just this map is W string and join. It's an empty string. Move this over here. Why don't you like this? No method join? What? Okay. this is a valid model number. We're gonna do this, and well, I don't even think that we need to break out of this loop. This is unused, I guess. No, yeah, this, I don't need you. I don't need you either. Oh, we have different model numbers that are valid, but I guess the last one is the biggest. Whoops. Copy. I'm nervous now. Is this correct? Is this correct? Oh, no, this is not the right answer. Your answer is too low. What? How can this humongous number be too low? I was so excited about that. Too low. Please wait. The subreddit. Okay. So my guess was too low. But it did get an r equals 0 when running the whole thing. Doesn't it? Did I make, where did I make a mistake, basically? That's the question. We are running this with this previous set. Am I confusing? Wait. Wait, which are the 5? These are the last 5 numbers. And only a few of them were valid. Model numbers reached z equals 0. What are we missing? Let's do let's whole program. Wait, what I want is this. This would be the whole program. I want to check. This should be all inputs. Let's all inputs be this. Let's double check this. If we do run a loop program of the whole program with all the inputs, with the initial variables, this, no debug. Let's results again, assert rest3 or assert equal rest3 is 0. And just to make double sure, let's copy the whole input again and paste it here, so we don't have any blank lines or anything, and run it like this. Are these still valid? Yes, they are. And the biggest should be this, right? That is the thing that I tried before, and it said that it was too low. Oh man, this is so brutal. This is so brutal. Like, how can this not be? What is the largest model number accepted by Monad? This is the largest of these, right? Yeah. Yeah, this is clearly the largest of this bunch. This is the same answer that I tried, right? Wait, it's not this 971. Is this not the same answer? What? Wait, why is the 95 here and I tried and now I'm seeing 97? What the hell? What did I try before? Like if we don't do this check, do we get the same output? Yeah, whole program is not used. Well, now 99? What? What's going on here? Is this not deterministic or something? 90. What? This is not deterministic. Okay. I mean, this seems bigger. I made a huge mistake here. This is not the right answer. It is too low. Okay. Okay, there is something probably regarding hash iteration order that is making this thing not deterministic, which is beautiful. It's now like, what the hell is happening? So insert. Value is updated and the L value is returned. The key is not updated. What the hell? How can this not be deterministic? Like I get different results when running different times. And they are all valid when I'm running the whole thing. So at least we are getting valid model numbers. Yeah. It's a valid model number. Let's print just the result here of the whole program to see. I mean, yeah, it looks like the variables that we expect to have. Sure. Is this correct? Like, I'm doubting everything. If I add, I don't know, let's add just 15 to x. Let's add 42. To x. Do we see this output? Yeah, okay. It's running the thing. They are valid model numbers, sure. why is the iteration okay, what happens if this set values are not sorted? Yeah, we were trusting. Okay, I think I know what's happening. We need to iterate this and keep the largest. We always need to keep the largest. That's the thing. If we don't do that, yeah, because in each of these nested for loops, we are iterating in order, so that's no problem. But so the first loop, this thing should be no problem. But after this, the iteration of this hash is not in order. So what happens with this? It's not guaranteed that the highest set inputs, no, sorry, the highest, set inputs is what we want for that specific set are going to be the largest ones. No, but for that, yeah, I'm doubtful about this. So what I want to do is say something like, hey, set2, give me the entry I still cannot type sets. Give me the entry for this or insert this wait, entry, yeah, and modify, that's what I want, or insert that. So if there was one before, I want to keep the largest, right? So let's say and modify I don't know, value, whatever. And what is this value? Yeah, immutable, right to that. So we are going to do, hey, keep the maximum. Do we have like a maximum between this and these? Shall we? Can we? I think that, yeah, that arrays can be compared like lexicographically. So this is horrible, but I'll take it. If we do that, let's run now. Do we keep the same type? Must be known at this point. Sure, but why does Rust Analyzer tell me that this is oh, okay, I thought that you knew this. This V should be of type I64-7, or I guess mutable reference to this shit. Okay, thanks, type inference. So if we run now, Okay, we still get results, but they are still not in order. But let's recreate this approach on the other inserts. So here we are inserting this. These are 9 inputs, so this is going to be a 9. I'm going to shamelessly copy paste this, and this is set 3. Okay, it compiles. Does it run? Do we still get valid model numbers? We do. Are still they unsorted? They are. But let's try again. This should be the last one, I think. What a mess. What a mess. We are iterating these. We should probably have should keep the largest here. So we're gonna need a sets 4 to insert into. Okay, we are going to insert this all inputs thingy. We have a variable for this, so let's do this and this, and have let sets 4 equal hash map new. This should be mutable, of course. Mismatch types. This should be an array of 14. It compiles. So now, now let's print len. This sets 4, which should have only one value, and it should be the biggest number, right? I think it should. We can leave all the other mess. If we run this, what do we get? Wait, we are not getting. What are we messing here? Like, why are these so different? Like 24 and those, what's happening here? I don't know what's happening here. Why? Comparison to values. So I'm not sure if this max is doing what I want to do, but like really the first things that we have, like of the first set values, how can we have such different ones? Or what am I messing here? Do we need to keep here when we insert, this should be fine, I think, because we are going to keep the last one and we are not iterating over sets from before. This should be safe. To insert like this. Then in here, I'm not so sure if this is really correct. We should keep the maximum for that set, so y let's check the documentation for Rust array. Comparison. Well, not like this. Prevents comparison of arrays lexicographically. Okay. Can we visit this lexicographical comparison? Or I guess in the documentation of ord lexicographic ordering. Okay, yes, I'm trusting that arrays are compared lexicographically, and this we should retain the maximum. But we have this evident problem of the iteration not being deterministic, and this really has to do with hashing. Sure. So what do I want to do? What do I want to do? I want to and this is so stupid. How can this be so out of order? I mean, yeah, I have no chance of hitting. Like sometimes we have pretty big numbers, but it's no guarantee. Okay, I think I'm like getting drowned in a glass of water, so I think I will stop the video here and come back to this with fresher eyes in, I don't know, in some time. Yeah, I should take more breaks when doing this, but I feel like we are so very close because we are actually running, we are getting valid model numbers, but we are having a stupid bug related with ordering of iteration. So why are we hitting that? I'm not really sure. I would have assumed that we were should always be keeping the maximum numbers given this. But yeah, this is probably a very stupid bug. And I have to fix it, but I am a bit dizzy at the moment for this long session, so I will continue this later. If you have been, thanks for watching and see you later. Bye bye.